Okay, November 2021, paper 2, variant 1. In question 1, it is actually cancelled. Why? Because the micrometer screw gauge has been removed. So you can cancel out question 1. Question 2, diagram shows the distance time graph for 4 objects. Which graph represents an object moving with an increasing speed? Increasing speed would be D. Why? Because this is a distance time graph. B is actually a constant speed. It's moving with a constant speed. Question 3. Which row states the mass and the weight of the object on the moon where the gravitational field strength is 1.6? It has a weight of 6.4 where the gravitational field strength is 10. Can I find the mass? Yes, the mass would be equal to, as you said, weight over g, which is 6.4 over 10, 0.64. So this is the mass, and the mass will not change. Can I find the weight? Yes, by multiplying it by 1.6. So it would be B. I'm sorry. It's not B, it's A. Okay, when you multiply it by 6, it would be A. Which substance has the lowest density? Can I find the lowest density? Yes, density equals mass over volume, 1.2 over 1. Okay, 1.2 over 1. 1.5 over 1, so this is 1.2, the other one is 1.5, 1.8 divided by 2, which is 0.9, and the last one is 1.0, so the least density is 1. 0.9, C, yes. A 20-meter long uniform bridge of weight 100 kilonewtons. This is the weight of the bridge. Pillars exert forces T1 and T2. So you have the van, okay, a van, which is 24 kilonewtons, 5 meters from the left-hand pillar. From the left, this is a distance of 5 meters, right? Can I find T1 and T2? Yes, I can find it by assuming that one of them is the pivot. Okay, so if I would like to assume that T1 is the pivot, for example, if I would like to assume that T1 is the pivot, then T2 would be, let's say, moving, or there would be a force at T2. What if you want to assume that T2 is the pivot and that T1 has the force? It's okay, as you like. As you like. It's up to you. They would both give you the same result, or the same result. Now, if T1 is the pivot, then the force times distance is 0, and therefore there is no moment due to T1. Now, is there a moment due to T2? Yes, the moment due to T2 would be T2 times the total distance, which is 20. Right? I need to say that clockwise moment equals anti-clockwise moment. You have the 24 and the 100 kilonewtons. These are clockwise moments, right? So 24 times the distance of 5, 24 times 5, plus 100 times the distance of 10, right? Because this is at the center of mass, so the distance is 10 meters times 10 equals the anti-clockwise moment, which is T2 times 20. Can I solve for T2? Yes, I can solve for T2. What is 24 times 5 plus 100 times 10? Well, this gives you a total anti-clockwise clockwise moment of 1,120 times 20 divided by 20. When you divide this number by 20, this would give you a moment of 56, a total force of 56. Therefore, it has to be C. C is the only correct answer. If you solve for T1, it would be, can I solve for T1 in this question? Yes, I can solve for this T1. You'd say that the upward force is equal to the downward force. Okay, if you had, for example, more than one answer with 56, okay, you'd say upward forces equal to the downward forces, in which T1 plus T2 would be equal to 100 plus 24. Okay, spring, which obeys Hooke's law, has an uncertain length of 10 centimeters, a load of 20 newtons is suspended, the new length is 36. What is the spring's constant? K equals F over X. The force is 20 newtons, but the X, the extension. What is the extension? It's 36 minus 10. 36 minus 10, which gives you a K of 0.77. Can I find the impulse? Can I find the impulse? Yes. Impulse would be the change in momentum. That's it. Change in momentum, and that is it. If you had the force, you would have said force times time. Electrical energy may be obtained from nuclear fission. In which order is the energy transferred in this process? Nuclear fuel to the generator, nuclear fuel to the reactor and boiler, and then generator turbines? No, turbines and then generator. D. Which equation is used to calculate the time? If you had the power, the force, okay, distance and the time taken, you can't find the time. Yes. Why? Because they say that the power is the energy over time, or the force times distance, over the time, right? Work done over time, basically. Can I find the time? Yes. Force times distance over power, which is B. Question 10. Uses an electric motor to lift a load the vertical distance of 2 meters. Then he increases the power. He increases the power. The efficiency does not change. Which row describes the effect? Does the work done change? No, it does not change. It stays the same. Why? Because it's the same distance. Okay? The same distance. It's the same load and the same distance. What about the time taken? If you increase the power, then the time taken would decrease. If you increase the power, the time taken would decrease. Yes. 4 containers are filled to the top with the same liquid. The base of each container is circular. Which container has the greatest pressure exerted? The greatest pressure would be due to container A. Why? Because it has the least area. Liquid is evaporating, it's not boiling. Which statement about the liquid is correct at an instant in time? At an instant in time. Any molecule can escape? No, only molecules with high enough energy can escape. From any part? No, only from the surface. This is evaporation. Diagram shows 2 cylinders connected by a narrow tube fitted with a tap. One cylinder contains 80 centimeters cubed of gas at pressure 2 times 10 to the power of 5. Other container contains a vacuum. The volume of the evacuated cylinder is 20 centimeters cubed. The tap is opened so the gas can flow to both cylinders. The temperature remains constant. What is the new pressure of the gas? Can I find the new pressure? Yes. P1 V1 equals P2 V2, right? P1 V1 equals P2 V2. We need to find P2, right? The initial pressure was 2 times 10 to the power of 5, and the initial volume was 80. We need to find P2, and V2 would be, so a lot of you might say that V2 is 20, right? But that's wrong. V2 would be the total volume of both cylinders together, which is 20 plus 80, meaning that the volume has increased, and therefore the pressure will decrease. So basically, to find P2, you would say 2 times 10 to the power of 5 times 80 divided by 20 plus 80, or basically divided by 100, giving you a final pressure of 1.6 times 10 to the power of 5. Now, an aluminum block has a mass of 200 grams, specific heat capacity. How much energy is required? Can I find the energy? Yes, E equals mc delta T. The mass is 200 joules, 200 grams, but you need to convert this mass. Why? Because the specific heat capacity is in kilograms. So the mass is 0.2 kilograms times C, which is 900, times the delta T, 110 minus 20. 110 minus 20, which would give you a final answer of almost 16,200 joules. Okay? 15 is cancelled. Liquid thermometers have been removed. Which row is correct for the materials of the base of the pan and the handle? The base has to be a good conductor, while the handle has to be a poor conductor. B. In question 17, the gap, we have a gap. The waves approach the barrier. The size of the gap is about the same size of the wavelength of the ripples. The gap is increased. The gap is increased. What happens? What happens? The ripples are closer together. No, you do not change the wavelength. Further apart again. They're more curved or less curved. When you increase the gap, what happens to the amount of diffraction? It actually decreases. Diagram shows a wave. Which row correctly shows the amplitude and the wavelength? The amplitude would be the distance between 1 and 2, right? Distance between 1 and 2 is the amplitude. What about the wavelength? Distance between 4 and 5? No, it's actually between 4 and 6. This is the total wavelength, or one wavelength, yes. Two beams of light are both the same color of red. One beam is traveling through air, the other beam is traveling through water. Each beam has a different brightness. Which quantity is the same for both sets of waves? Both sets of waves have the same frequency because they are the same wave. Which of these is the angle of incidence? Angle of incidence is Q. Is this total internal reflection? No, it's not, because of this wave. This is partial reflection. Partial reflection. 21. Diagram shows a ray of light in glass incident on the surface between glass and air. What happens if the angle of incidence is made larger than the critical angle? If it's made larger than the critical angle, then total internal reflection would happen. The angle of refraction becomes 90. No, there is a refracted ray. Again, refracted ray only. No, there is a ray reflected. Yes, reflected inside the glass. Total internal reflection. Question 22. The sun emits infrared radiation. Light from the sun reaches the earth in 8 minutes. Which row gives correct information about the infrared radiation? So infrared radiation travels at the same speed of light, right? What about the wavelength? What about the wavelength of the infrared radiation? It's longer. Yes, we know that it is longer. Time taken. The time taken to reach the Earth would also be 8 minutes because it has the same speed. Which list shows regions of the electromagnetic spectrum in order of increasing frequency? So you need to start off with the smallest frequency. Not X-rays, infrared, visible light, ultraviolet X-rays. Yes, this would be correct. In question 24, what is ultrasound? Ultrasound is sound with a frequency higher than, yes, frequency too high pitched, not too loud, too high pitched for humans to hear. Question 25, what is the movement of charges? This is a uncharged metal sphere, right? It's an uncharged metal sphere. It does not touch the metal rod, the positively charged rod, and it does not touch the ground, right? It's uninsulated. It is insulated. So what is the charge on the sphere? If you think about it, what is the charge on the sphere? The charge on the sphere will remain neutral. Why would the charge on the sphere remain neutral? Because it still has the same amount of protons and electrons. What about the movement of charges? The movement of charges would be that the negative charges move to the right. Why? Negative charges move to the right because they are attracted to the positive rod. Okay. 26. In which circuit is the ammeter basically placed correctly? This is the B, only B. In which circuit does the direction of conventional current and the direction of the electrons? Okay, so the electrons move from the negative to the positive, right? From negative side to the positive side. And the conventional current moves from the positive end to the negative end. So if we think about it, let's see. An A from positive to negative, is this the, no, this is wrong because I is the conventional current. Again, still wrong. This is wrong. And C, let's see. So we have I, it's moving in this direction. Yes, it's moving in this direction. What about E? It should be moving in the opposite direction, which is correct. Yes, it is C. Question 28. A voltmeter is connected across the 1 ohm resistor. The reading is 6 volts. As it's at this position, it reads 6 volts. When P is moved to the end of the circuit at point Y, what is the new reading on the voltmeter? If you think about it, this is a potential divider. This is a potential divider. Why? Because he had 1 ohm when it was reading the potential difference of only one resistor, at 1 ohm, the voltage was 6 volts. At point Y, is it reading 2 ohms only? Is the voltmeter connected across the 2 ohm resistor only? No, it is not. It's actually connected across 3 ohms of resistance. 3 ohms of resistance. So if you cross multiply, you'd find that the potential difference is 18 volts. If you cross multiply, 6 times 3 divided by 1 is 18. Graph shows a current voltage relationship for a circuit component X. For a circuit component X. What happens to the resistance of X and what happens to the temperature of X? What happens to the resistance? So as the graph is, it's actually curving towards the current, right? It's curving towards the current. What happens to the resistance? The resistance decreases, right? The resistance decreases. What about the temperature of X? The temperature of X increases. This is a, think about it. What is this component? This is a thermistor. This is a thermistor in which the temperature or the resistance is inversely proportional to the temperature. Question 30 is cancelled. Moving on to 31. Which circuit do both lamps light? Both lamps. We need both lamps to light. A, none would light. B, again, none would light. Why? Because if the current passes, it would be blocked. So B is wrong. What about C? It would pass through the first one and the second one normally. So yes, it is C. In D, it wouldn't pass through the second one. So it is wrong. 31, you have two resistors in parallel. What is the resistance of the parallel combination? When you have two resistors in parallel, it has to be less than either one. Total resistance decreases. 33, the metal cases of electrical appliances are connected to an earth wire. Which statement is not correct? Which statement is not correct? If you have metal cases, earth wire, not correct. Again, think about this question. Not correct. The live wire may become too loose and touch the metal case. Yes, this is correct. This is correct. That's why we have an earth wire. That's why you have an earth wire. If the metal case becomes live, the earth wire conducts current to the ground. Yes, so both of these statements are correct. The earth wire needs to have a high resistance. No, it needs to actually have a low resistance to be able to conduct the current easily to the ground. What is the function of a split ring commutator? Split ring commutator, what does it do? Enables the, no, reverses the current, once every revolution, no. Reverses the current whenever the plane becomes perpendicular to the magnetic field. Yes. Why? To be able, or to make the coil, to keep the coil rotating in the same direction, Which graph represents an AC current? Only AC current would be A. Why? Because it's moving from the positive end to the negative end. D, it's not AC. Why? Because it's only in the negative side. It's only in the negative side. Question 36 might be a bit tricky. Question 36 might be a bit tricky. So you have a magnetic field, you have a current. Okay, when there is no current in the wire, the reading is 0.35. When there is no current in the wire. When the current is now moving in this direction, what happens to the reading on the balance? Okay, let's think about this. You have this wire, the wire is actually fixed in place. The wire is fixed in place. The wire does not move. The wire does not move. Okay, the horizontal wire is firmly held at each end. It cannot move. This is the whole point of this question. It's that this wire cannot move. Now, if you take a look at this view from above, you have a current in a wire and you have a magnetic field. Can I use my Fleming's left hand rule? Yes. Fleming's left hand rule, you'd have the first finger pointing to the right, north to south, right? And then the current is moving downwards, and therefore the force on the wire, would be out of the page, right? The force on the wire is what is out of the page, right? Okay. Force on the wire is out of the page, right? So the wire needs to move outwards, but the wire cannot move. The wire cannot move. So what will happen is that there will be a reaction force. A reaction force in which the wire will actually push the magnet downwards. The wire wants to move upwards, but it cannot. So therefore it will push the magnet downwards, meaning that the reading on this balance would increase. Why? Because the magnet is actually being pushed downwards. The wire wants to move upwards, it cannot, therefore it has to react. How can it react? By pushing the magnet downwards. Relatively compare, you'd find actually that the wire has moved upwards relative to the magnet. Even though the wire has not actually moved, the magnet has actually moved. In which direction? It has moved downwards. Okay, it's a quite a tricky question. It's a bit tricky, I know. But that's the whole point. The key word of this question is that the wire cannot move. The wire cannot move. Okay. Question 37. Nucleus contains 146 neutrons, 95 protons. It decays by emitting an alpha particle. How many neutrons and how many protons remain when this form of americium decays? How many protons and how many neutrons are remaining? Alpha is 4 and 2. So a lot of you might say only 142 neutrons are remaining, which is wrong. Why is this wrong? Why is 142 wrong? Because this is not the mass number, this is the amount, this is the number of neutrons. Alpha contains 2 neutrons and 2 protons. So the number of neutrons would decrease by 2, and the number of protons would also decrease by 2. Okay, this is not the mass number. The graph shows how the count rate measured by a radioactivity detector placed near a radioactive sample is changed with time. Given that the background radiation is 30, what is the half-life of this sample? The initial count rate is now what? The initial count rate is 530. Can I just divide 530? No. If you have background radiation, minus, divide, plus, right? Minus, divide, and plus. Not plus with an E, it's only plus. Plus. So 530 minus 30 is 500. You need to divide 500 by 2, which is 250, and then you add 250, you add the background radiation, which is 280. From the graph, you need to draw a line from 280, which would reach this point exactly, right? It would reach this point exactly. At this point, you need to draw a vertical line, which would be 3.4, yes, 3.4. Teacher holds a radioactive source near a detector. The reading on the detector is 320 counts per minute. The detector is switched on again after the source has been removed and shows a reading of 20 counts per minute. What is the counts per minute solely due to the source? Due to the source, it is 300. Why? Because you have a background radiation of 20. Yes. What about the reason for no? This is the background radiation. Now, that's easy. Which statement is not correct? Which statement is not correct? Alpha particles are used to detect cracks in metallic structures. No, they are not used to detect cracks, they wouldn't even be able to pass through these cracks. Okay,